for the next presenter, we go with Professor Tamer Sebaey. He's from Prince Sultan University in KSA. Without further ado, please go ahead. The floor is yours.
This is Tamer Sebaey. I'm from Prince Sultan University from the Structural Material Lab. I'm here to talk about the crashworthiness of composite structures as part of the automotive application. Actually, crashworthiness is related to the case of having an accident. In 3 minutes, I will try to give a little bit about what's the problem. The problem is that those images and more images are part of our daily routine. Every day you can see those images, and as a result, in 1 year we have almost 7,000 persons were killed in car accident. Almost half a million car accident in 1 year in Saudi Arabia. And the result of this in Saudi Arabia, the KPI is 28, whereas the international standard is that this KPI should be 8. Actually, this is against the Vision 2030, while we are improving the lifestyle of the person and the safety of the person. So we should take an action regarding to this. We should try to improve this. Well, going very closely to the car during the accident, what will happen is that this structure is trying to capture most of the impact, most of the energy is going to the structure. In terms of fracture, elastic deformation, plastic deformation, of course, the rest of the energy is going to the person inside. Having the seatbelt and the airbags are very important, but still, we still have a problem, is that any change in the force means that change in the acceleration means that braking. Okay, well, to have a structure with higher absorption to the energy during the crashing, and also a steady state crashing, which is the green line. Okay. Example for the fiber, we found that for the same pipe, the fiber orientation makes a big difference in the initial crashing load. And also for the geometry, we have a lot of geometries running there. And this is just a sample. Actually, we did a lot on the geometries, as well as using hybrid, using different fiber. We found that using the Kevlar fiber with the carbon can improve a lot, can absorb a lot of energy. Actually, we have the date palm fiber as well with the carbon. Also, we use the dynamic. Recently, we are working on the effect of thermal aging on the crushing, and what we found is that increasing the temperature is dramatically reduces the whole stuff, reducing the energy absorption of the same device. And in the near future, we hope to use the natural fiber in the energy absorption device, and very specifically in the dead palm fiber, as Dr. Fahd mentioned a few minutes ago. We have a lot of waste material from these dead palm fibers we can use as part of the energy absorption, as it can absorb a lot of energy during the crashing. And also, we hope to start as soon as possible a project on 3D printed material in crushing. So we 3D print the energy absorption device and then test it. Actually, this is most of this work is already done. We hope the last 2 items to have funding through any funding body for the next couple of years to start these 2 projects as soon as possible. Thank you very much. And if there is any question, I will be more than happy. Thank you.
I think we have a question here from Dr. Ahmed.
Yeah, my question is to Dr. Tamer Sebaey. First, I would like to welcome him here. So my question is only based on the natural fibers. How do you plan to use them? And the application it's to make a hybrid material from natural fiber or from palm tree with carbon or glass or Kevlar or what, any other kind, or just you plan to extract cellulose and start the process from the beginning to use the cellulose to build fibers and then use them. Can you explain a little?
Thank you, Dr. Ahmed, for your question. I will try to summarize the things. We will start with the natural fiber coming from the palm tree by chemically treating the fiber, so the fiber itself improve the interaction between the natural fiber and the polymer, whatever the polymer that will be used in the future. And then in the design stage, we are going to select based on modeling, based on prediction, select the type of other fiber, either it's glass or Kevlar is a very good fiber in terms of the energy absorption. So it's the first candidate, and for the strength, carbon fiber is the other candidate. So this max can provide a very good solution for energy absorption device that use date palm fiber as it's a waste material. Saudi Arabia is they don't know what to do with it, as Dr. Fahd just mentioned, and it's sustainable. So we are using the waste for something that's useful. So this is the main idea, and hopefully we can proceed with it.
Thank you. Thank you, it's clear.